This is Mrs. Cribb. We're going to go through the common errors for Chapter 12's quiz. So here is the results. First one was pretty good. Polar solvents dissolve polar solutes. So remember, like dissolve likes, and nonpolar would dissolve nonpolar. Polar dissolves anything with a charge, with a plus and a minus. Second question, you have potassium chloride, KCl. Remember, the potassium, the K, is a metal. It's the metal, it's in column 1. It has a +1 charge, and chlorine is a nonmetal. It's a halogen. So metal, nonmetal, ionic. So this thing has a positive side and a negative side. Butane, if you look at it, you see how it looks identical all the way around? It's like all these hydrogens, think of them as guys all playing tug of war. Nobody's winning. So it doesn't have a positive side and a negative side. So this butane is nonpolar. It can only dissolve other nonpolar things. So potassium chloride has a positive and a negative. It has a polar side, basically, a positive pole and a negative pole. So it cannot be dissolved by butane. So the answer was no. Number 3, will this dissolve in butane? And I ask you to look for the picture in question 2. Well, this is the molecule. It does not look the same all the way around. It has this OH group. That makes it different. This was this identical, or not identical, but very, very similar to the question number 1 on the practice that you did for this quiz. And this right here makes this side more negative. It's not exactly the same all the way around. So this is going to be a more negative side. This is going to be a more positive side. So this is a polar compound. This polar compound cannot be dissolved by this nonpolar compound with butane. So no, the answer was no. This is tetrabromide, carbon tetrabromide. Again, it looks the same all the way around. So it's nonpolar. So it can only be dissolved by another nonpolar thing. So this could be dissolved by butane, because butane's nonpolar. This is not polar. But it can't be dissolved by water, because water is polar. Water has a positive side and a negative side. That makes it's one of the very special things about water. The hydrogen sides are positive, and the oxygen side is negative. So let me look at Zernal for a minute here. Oh, let me erase this. I was just testing it earlier. So I'm just going to draw water real quick just to remind you about that. So water is H2O. And so we have oxygen and 2 hydrogens. Water is got a negative side and a positive side. So that makes it polar. Oxygen is more electronegative. It's stronger. So the electrons shift this way. So it's polar. Water is polar, and it can only dissolve other polar things. Okay? Let's go back to the results. Question number 5, about 84% got it right. What is the molarity of a solution that contains 3.54 moles in 450 milliliters? All right, so molarity, remember molarity, capital M, is moles of solute over liters of solution. Moles of solute, okay? So it's this one you'd have to just make sure you put it in carefully. The moles of solute were 3.54 moles in 450 milliliters of solution. So 3.54 moles in 450 milliliters. We'll see it's got to be in liters. So you take 450 milliliters and you turn it into liters. There are 1,000 milliliters in 1 liter. You have to remember this. A milliliter is a teeny drop. Okay, a milliliter is like just a drop of water. Okay, but a liter, think about a 2-liter bottle of Coke. It's half a liter, so it's a lot larger. So it's basically dividing it by 1,000, 1, 2, 3. And so it's 0.45. And is it got a zero, a decimal at the end? Let's see. Yeah, a decimal. So that means it's 0.450 liters. That was the value and the number of significant figures. And so that ended up being 7.87. Capital M for molar. Okay? Back to the results. So that was this one. I'm going to work this one out. 1.4, so about 75% got that one right, but we're going to work it out. I'm not going to work this one out because it's very similar. Well, I don't know. I might work it out. We'll see. Let's definitely do number 6, and then we'll come back. Okay? So this is number 6 right here. I'm going to erase some of this just so I can have room. So what mass of sodium sulfate would be needed to prepare 450 milliliters of a 2.5 molar solution? So the first thing you really need to do when you see these is take this molarity and turn it to the fraction that it's equal to. So we have a 0.25 molar is equal to the fraction 0.25 moles over 1 liter. And then you're going to set up an equivalent fraction. You want to know a number of moles in liters. Now this is asking for mass. I cannot figure out the mass here. I can figure out the moles, X number of moles, because the volume is 450 milliliters. And I've actually already converted 450 milliliters into liters right here. So we're going to put that here again, 0.450 liters. Because 450 milliliters, oh, right here is actually where I did it, 0.450 liters. So I took the milliliters, I divided by 1,000, 1, 2, 3, 0.450 liters. Okay, you first set up this proportion, right? Then you're going to cross multiply. So 0.25 moles times 0.450 liters equals 1 liter times X moles. Okay? Now I'm going to divide both sides by 1 liter. So the liters cancel. And that's going to tell me how many moles. All right, when I multiply 0.25 times 0.45, I get 0.11 moles when you account for significant figures. I only need 2 sig figs in that number. This one has 3, but this is a smaller number of significant figures, so 2 sig figs. All right, so that tells me how many moles, but the question was mass. So that means I got to convert the moles to mass. So I take 0.11 moles, and I'm going to need the molar mass of sodium sulfate to put here so I can get the mass in grams. Okay, so sodium sulfate, SO4, so 4 oxygens times 16. Sulfur is 1 times 32.06 or 0.07, depending on which one you're looking at. The one I'm looking at says 0.07. Sodium, this one has 2 sodiums, so 2 times 22.99. I had multiply these together. Okay, so 32.07 and 64, and I end up with 142.05 grams per mole. That would have been to get the full credit there. So 142.05 grams per 1 mole. Cancel out my moles. And then I just multiply these guys together, and I have it in grams. And when I multiply them together, I end up with 15.6, which rounds to 16 grams because of two decimal places. So 2 significant figures. Leading zeros are losers. So 16 grams is the right answer. Now, I think that some people just stopped with the moles. But you have to read the directions. Make sure you answer the question. It asks for mass. Moles is not mass. So that's one of the problems. Next question that I was going to work out is what will the volume of a 0.45 molar solution be? So what will the volume be, 0.45 molar, if it contains 60 grams of barium hydroxide? Okay, so we take the 0.45 molar, 0.45 molar, and we turn it into the fraction, 0.45 moles in 1 liter. Okay, now I'm going to set up a proportion or an equivalent fraction. All right, I'm asking this time what the volume will be, X liters. And so that means I'm going to have to be able to fill in this moles somehow. But I don't have the moles. I have the grams of barium hydroxide. So I can figure out the moles by mass, because this right here is the mass. So I'm going to turn mass to moles using the molar mass. That's what we did in chapter 8 a lot. Chapter 9. So we have 60 grams of barium hydroxide. All right, and so 1 mole, and I need the molar mass of barium hydroxide. Okay, so let's see here. I got to have 1 barium, and this 2 means I have to have 2 oxygens, and I have to have 2 hydrogens. So 1.01, 16.00, and barium which is 137.30. Remember, I get all these off the periodic chart. All right, you have to multiply that by 2 to get 32.00, and this is 2.01, and that's just 137. So I add that all together, 137.30 plus 32.00 plus 2.02, 2 times 1.01 is 2.02. I get 171.32 grams per mole. All right, so this time I want to turn the mass to moles. I put the moles on top. 171.32 grams. All right, so 60 divided by 171 gives me 0.035 moles. Okay, that number of moles is what goes here, 0.35 moles. Okay, so I turned the mass to moles first. To put it here, I have to make the fractions equal to each other. Now what do we do, guys? We cross multiply to solve. So 0.45 moles times X liters equals 0.35 moles times 1 liter. All right, I want liters, so I have to divide both sides by 0.45 moles. 0.45 moles. So moles cancel. So now it's basically 0.35 divided by 0.45, and I get 0.78 liters. That's the answer. I got a few strange answers. I'm not really sure where they came from yet. I'll look soon. But this is how you do this question. So please review this one if you think that you missed it. Okay? Let's go back to here for a minute. So I just covered this one, number 8 and number 6. I didn't do number 7. More of you got that one correct. I'll basically, let's see, calculate the molality of this solution. I'll go ahead and do number 7. Let me just see. We have 1.4 grams of C2H6O2 and 6.5 kilograms, both of them are kilograms rather, of water. So first you look which one is the solute. Well, the smaller one is the solute. So it's going to be 1.4 kilograms of this, and 6.5 kilograms of water is the solvent. Okay, so let me just write this down here for a minute. We have oh goodness, I forgot. Let me look at that again. There it is. We have 1.4 kilograms of C2H6O2, and we have 6.5 kilograms of water. All right, so this one then is the solute because it's the smaller amount, and this one is the solvent. Now, I asked you to calculate molality, and molality is the moles of the solute over the kilograms of the solvent, not the solution this time. So the solvent I already got the kilograms of, 6.5 kilograms. But I don't have moles of solute, so I have to convert 1.4 kilograms of this stuff into moles. So 1.4 kilograms, I first have to turn it to grams, because 1,000 grams are in 1 kilogram. Remember, a gram is like a paper clip, and a kilogram is 1,000 of them. And moles is always, the unit for moles is always grams per how many grams are in 1 mole. So we're talking about grams. So the molar mass is grams per mole. So kilograms cancel, and now we're going to just have grams of that. And then I'm going to have to figure out the molar mass. And so the molar mass, I'm just going to tell you the molar mass, because it's 2 times 12.01, hydrogen is 6 times 1.01, oxygen's 2 times 16. You multiply and add all those together, we get 62.08 grams per mole. So you may have not multiplied those together or something, but there's the molar mass. So 62.08 grams in every 1 mole. See, I had to get it to grams, so the grams on top and the bottom cancel. We already had the kilograms cancel. So when I multiply 1.4 times 1,000 divided by 62.08, I get 22.55, but only 2 sig figs, so 23 moles, which is part of the answers for this. And so now I take the 23 moles and I put it on top here. so I can calculate molality. So 23 moles divided by 6.5 kilograms was 3.5 little m for molal. 3.5 molal. So that was that question. All right, so back to the quiz. So that was this question here, number 7. Number 8 I worked out. So let's see whichever one I have now. All right, this one here. You dissolve 350 grams of magnesium chloride. What is the molality? Enter your molar mass and then the molality. First of all, you guys have got to pay attention to the instructions. I give you an example of how to put the answer in so that you will do it as I choose, just so that I can see your numbers. You have to answer it and enter in everything I ask for. So if you did not enter in both answers, you're not going to get full credit. All right, so we're going to dissolve 350 grams of magnesium chloride in 800 grams of water. What's the molality? Okay, molality. Moles of solute over kilograms of solvent. Okay, this is the solute. So I'm going to have to figure out the moles for that. And this is the solvent because there's more of it. So I already know that 800 grams has to be turned to kilograms. So turn 800 grams into kilograms. There are 1,000 grams in 1 kilogram. Grams cancel. It's 0.800 kilograms. So that's what goes on the bottom, 0.800 kilograms. Okay, 3 decimal places because this has 3 sig figs. So I have to keep 3 sig figs here. Now I got to turn the 350 grams of magnesium chloride into moles because the solute has to be in moles. If you hear any screaming in the background, my grandson's in the other, two of them are in the other room. So 350 grams of magnesium chloride. All right, so I need to know what the molar mass of one molecule of magnesium chloride is. So we take magnesium and chlorine, and magnesium is 24.31 and chlorine is 35.45. There's only one of each. No, there's 2 chlorines right there. See it? 2 chlorines. So 2 times 35.45 is 70.90, and then 24.31. Add that together, I get 95.21 grams per 1 mole. So 95.21 grams. That cancels. 350 divided by 95.21 is 3.68 moles. So that was part of your answer. We had 3 sig figs here, so we had to have 3 here. So that's how many moles? 3.68 moles. Divided by 800 kilograms, or 0.8 kilograms, is a 4.60 little m. There has to be 3 significant figures because there's 3 here and 3 here. There's 3 significant figures here because that decimal place makes this have 3 sig figs. So if you people put 4.6, you lost 1/4 of a point for that. So it's if you only gave me this answer, because that is the final answer, what is the molality? You're not going to get the full credit because I ask you to give me the molar mass and the molality. So make sure you're fully answering the questions. Be careful about that. All right, let's go back to this. So that was, we've done this question. We've done this question, number 8. Number 9, we're going to do this one. What is the percent by mass? Okay, and so I'm pretty sure I put that on there. Yeah. What is the percent by mass of this solution of sodium hydroxide if you have 36 grams of sodium hydroxide in 250 grams of water, and then I gave you this? Well, if you looked at your notes, the percent by mass is what? The mass of the solute divided by the mass of the solution times 100. All right, so this is the mass of the solute, 36 grams. The solute's always the smaller amount. What's the mass of solution? Well, this is the solvent. So the solution, you have to add the 36 grams of the the 36 grams of the solute to the 250 grams of the solvent. So that has to be 36 plus 250 times 100. Okay. All right, so when I do that, I'm actually looking for my key, so there it is. I end up with 36 divided by 286 times 100, and I get 12.6 and two significant figures, 13%, because this has two sig figs. I think some of you didn't add these two guys together. I think some of you only divided by 250, which is the solvent. But you have to divide by the solution. That's why this was here, to make you realize that the solution is both of them added together. So that was a pretty common error as well. So let's go back to it. So that was this one. All right, so here, what is the solute? Of course, it's always the one that's smaller. 97%, got it right, 97%. The bonus, what is the I value? If you dissolve 350 grams of magnesium chloride in 800 grams of water. Well, since magnesium chloride is a solute, magnesium chloride is ionic. Metal, nonmetal. Magnesium is a metal. Chlorine is a nonmetal. Metal, nonmetal, ionic. And with ionic, you have to count the atoms or the ions. So magnesium chloride, you have one magnesium and two chlorines. So 1 plus 2 is the 3. The I value was a 3. And 76% got that correct. All right, next, enter your molar mass and then solve molality. A lot of you got this one correct. We have 350 grams in 800 grams of water. What's the molality? And I ask you, enter your molar mass first and then the molality. So, let's see. Let's go ahead and do that one. 350 grams of magnesium chloride in 800 grams of water. So let's go back to Mazernal here. I'm going to erase this so I have some room to work it out. So sorry about that. I should have done this sooner, but I didn't think I was going to do this many working out. But I do want to, just in case you need it for a redo. Okay? All right. So we had, did I already work this one out? I think I just worked it out. Grams and 800, yeah, 350 grams and 800 grams of water. So yeah, we're good on that one already. So that was this one. 350 grams, what's the key? And 800 grams of water. Now these are bonus questions. What is the new boiling point? What's the new freezing point? I'm not going to work those out because we worked them in similar questions in another place. So let's just look at the graphs. We got 86% got this right. How many grams of sodium nitrate, NaNO3, can be dissolved in 100 grams of water? That's what this is, 100 grams of water at 40 degrees Celsius. So all you have to do is find 40 degrees, go up until you hit the sodium nitrate. There's the sodium nitrate line. It hits right there. And you go across and read it. Now that is not 105. 105 would be right exactly halfway, because that's 100 and 110. 105 would be exactly halfway. That's lower than 105, but not all the way down to 100. So that gives me 102 was really the only answer that was close. It was not 100. So a few people chose 100, but you can clearly see that 100 grams is below the line. That would have been an unsaturated solution. All right, now at 60 degrees, if I dissolve 110 grams of potassium nitrate, what kind of solution do I have? 94% got that right. That was good. A saturated solution. The next one, 83% got right, unsaturated. Well, let's look at that one. 60 grams of ammonium chloride at 90 degrees, what kind of solution? So ammonium chloride, there's the line, ammonium chloride. And then what did it say? 60 grams at 90 degrees. So here's 90 degrees. Go up. There's 60 grams. Notice that there's the point where 90 degrees and 60 grams intersect right here. Ammonium chloride line is above it, so this had to be an unsaturated solution. Okay, how many grams of salt would be sitting on the bottom? You have 80 grams of ammonium chloride at 80 degrees. All right, so 80 degrees. And I try to dissolve 80 grams. Well, you can see there's 80 gram mark right there. There's the ammonium chloride that I asked for. See, NH4Cl. All right, and I forgot the temperature. 80 grams, 80 degrees. So 80 degrees and 80 grams. 80 grams is right here. That's way above this one. So how much would be the saturated solution? Well, whatever that is. So that's somewhere between 60 and 70. So I'm going to say 66 because it looks like it's a little above the halfway mark. So 66. So 66 grams could be dissolved, but I tried to dissolve 80 grams. So that means 80 minus 66 is how much? That much would be sitting at the bottom, between 80 and there. 80 minus the 66. That gives me 14 grams. That's the correct answer. So that's where that number came from. Okay, that's the only one. Okay, the other things are honors questions, and we're not going to go over those in this. So I hope that helps you. And you can review these if you need to. But if you're going to take the re-quiz, you have to. So I'll see you soon.